and D controllers. That is nothing but the proportional and the derivative or the differential controller. And to begin with, we will be learning the block diagram first. We will be feeding the reference signal here, and moving on, we will be having the summing point at the next interval. Now at the summing point, the feedback signal from the plant output is measured and it will be fed as input to the summing point here. Now at the summing point, this feedback signal and the reference input, they get summed up here, and that gives rise any difference between the reference input and the feedback signal will give rise to something called as the error signal. Now this error signal is fed as an input to our P and D controllers, and based upon the input, this P and D controller, it processes the error signal and gives us the manipulated output here. Now we have to see what happens here. Now this manipulated signal is fed as an input to the plant, now which stimulates the controlling action that has to be taken inside the plant in order to achieve the output, whatever the output given by the plant, that should be equal to the desired output that should be produced by the plant here. Now when the plant produces the output based on the correction signal or the manipulated signal which is given by the P and D controllers, that output is measured by the feedback element, and that is called as the feedback signal represented by B of S here. Now this will be summed up at the summing point. Any difference between the desired output and the actual output or the reference input, that gives rise to this error signal. This is the basic concept here. Now moving on. Next our aim is to find the relationship between the output of our PD controllers with the input of our PD controller. Output is the manipulated signal and the input is the error signal. Now we will be having expressing the relationship between this output and the input to the PD controllers by making of use this equation here. Now this manipulated output M of t, it contains two terms on its RHS term. The first term, it represents the relationship between the manipulated signal and the input error signal, considering the proportional control here, and the second term of our RHS, it expresses the relationship between the manipulated output of our P and D controller, considering the differential action of the differential controller in the P and D controller here. So that our first term, we will be writing the relationship between the manipulated output and the error input is given by M of t equals Kp times the E of t, where the relationship between the manipulated output and the error input is proportional. There is a proportionality existing between the output and the input now. Now moving on, considering the second term, it expresses the relationship between the output and the input in case of the differential or the derivative controller here. Now here what we will be writing, M of t equals Kd, that is nothing but differential gain, multiplied by d by dt of dt. Now this can be put in a sentence as the manipulated output in case of this P and D controllers is proportional to the time derivative of the input error signal in case of this derivative or differential controller here. Now moving on, in order to express this differential gain in terms of this proportional gain constant Kp, we will be making use of an equation, this one we have to remember this expression here. Now Kd, that is nothing but the differential gain, this is equal to Kp times Td. Now Kp is nothing but the proportional gain constant of the proportional controller, and T suffix d is nothing but the differential time here. Moving on, now I will be writing this Kd as Kp into dt. Now after writing this here, I will be applying the Laplace transform to this above equation, so that LHS part we have M of t, we will be converting from the time domain to the frequency domain, so that I will be writing this as M of s. Moving on to the RHS part, we have the proportional gain constant here, so that we will not be able to apply the Laplace transform. Constant will be written as it is. The next second we have E of t. Now E of t will be writing it as E of s after applying the Laplace transform here. Now second term, it has two constants here, Kp, that is nothing but proportional gain, and Td. Now we have expressed this differential gain in terms of proportional gain, hence we have written this one. Now Kp dt is a constant, will be written as it is. Moving on, next we have differential of dt. Now d by dt we have seen in the previous videos, d by dt I will be writing it as s, and E of t left the last term I will be expressing it as E of s here. Now considering this whole equation, the RHS part, we have this E of s in both the terms here. Now taking the like terms and rearranging, we will be getting the relationship between the output of our PD controllers to the input of our PD controller. That is nothing but the ratio will be expressed as the ratio of the manipulated signal to the input signal. We will be getting the expression as M of s by E of s. This is equal to Kp plus Kp into Td into S. This is the ratio of output to the input relation in case of PD controllers. Now coming to the characteristics of the PD controllers, as we know that whenever the proportional controller is used, it generally makes our system stable. The system will achieve the stable state very fastly. Second thing is, whenever we are using the differential controller, in case of differential controller, our manipulated output will be proportional to the time differential of the input, whatever the signal which is fed as an input to the system. Now, since because of this relation, the use of this differential or derivative controller, it reduces the errors that is produced in the output of the system. Last but not least, the combination of these P and D controllers, it produces or it improves the gain of the system. Gain is nothing but the ratio of the output to the input. It improves that ratio. Now moving on, the next is we have a graph here which relates the relationship between the output and inputs of the system in case of both individually, the proportional and as well as the differential controller. In case of proportional control, we know that the output is proportional to the error input signal, so that we will be having a straight linear graph like this one. In case of differential or derivative controller, we know that the manipulated output is proportional to the time derivative of the input error signal. Input error signal is 0, we will be getting some magnitude of manipulated signal as our output is, the input is 0, and we will be having certain output here. Hence our graph starts not from the origin, it will be starting at a certain point of the output and it moves linearly with respect to the input fed to the system. Now this is all about the P and D controllers, the block diagram, the input output relation, the ratio of the output to the input of the P and D controllers, as well as the characteristics, and this is the graph of the P and D controllers.